Hello, this is Mrs. Ross, and this is Lesson 8, Fractions and Percents. We're also going to talk about the inch ruler, and these are the starred problems from the written practice that you'll find on page 57 of your Saxon Course 2 textbook. Let's get started. Okay, use digits and a comparison symbol, so whenever you see this, it's either a greater than, less than, or equals. To write 1 3/4 is, fourths. Oh, narts. Okay, let's go back. We weren't done with this problem. Okay, 1 3/4 is greater than 1 3/5. Basically, what we're doing here is we're translating an English sentence into a math sentence. Number 2 says refer to practice problem I above and use a ruler to find x, y, and yz. We're going to skip this one. Skip. We'll have plenty of chances to measure. All right, list the single digit. So single digit means 1 through 9, y'all. Divisors of 1680. And I went ahead and put this divisibility rules here. I'm going to mark out the 10, 11, and 12 down here. And let's see what we can do. So it ends in 0, so we know that 2 works. If the sum is divisible by 3, so let's add these up and get the sum. 1 plus 6 is 7, plus 8 is 15, so this is my sum, and it is divisible by 3. If the last 2 digits are divisible by 4, and 80 is divisible by 4, it ends in 0, so it's divisible by 5. It's divisible by 2 and 3, so it's divisible by 6. Oh, what's the rule for 7? We haven't learned this one yet. Cross off the last digit, double it, and subtract it. Repeat. Okay, heck no. We're not doing that. Negatory ghostwriter. If we need to, we'll go ahead and divide it by 7 to see if it's divisible by 7. We can use our calculator, which is what I'm getting out right now. 1680 divided by 7. It works. All right, beautiful. Because that rule is crazy. Divisible by 8 if the last 3 digits are divisible. I don't know. Let's see. 6. Okay, so that's 8, 64, 40. Yep, that's going to work. So that's 8. 9 if the sum of the digits is divisible by 9. This is not divisible by 9, so this is as far as this is going to get. Okay? Let me change colors and we can do the next problem. Point A represents what mixed number on this number line. So let's see how many marks we have between 3 and 4. Okay, because we know it's going to be 3 and some change here. So 1, 2, 3, 4, 5. So there's 5 marks, which makes this 1/5, 2/5, 3/5, 4/5, and 5/5 would be 1 again. So what I have is I have 3 and 4/5 is my answer to that one. All right, what fraction of the circle is shaded? So we need part over whole. How many do we have? 1, 2, 3, 4, 5, 6, 7, 8. So the whole is 8, and I have 1, 2, 3 shaded. Okay. What fraction of the circle is not shaded? What's really cool is the whole circle is 8 over 8. That's 1. And I can subtract 3 8s and get 5 8s, or I can just count the ones that aren't. No problem. What percent of the rectangle is shaded? So let's see. We have 1, 2, 3, 5. Percent is per 100. I have 1/5 is shaded. So if I go up to my chart here, it says that is 20%. What percent of the rectangle is not shaded? So if the whole thing were shaded, it would be 100%. And I know that 20% is shaded, so I'm going to subtract that and get 80%. You could also use 4/5 and multiply 20 times 4 to get 80. Number 10. What is the name of part of a fraction that indicates the number of equal parts in the whole? What? What is the name of the part of a fraction? So we have the numerator, and we over the denominator indicates the number of equal parts Well, this is part and this is whole, so I'm not sure what they want, but we're going to go to the next problem. Okay. Oh boy, it's division. So here we go. If the variable's on top, we multiply. If the variable is on bottom, we divide. Okay? So E is equal to 15 times 15, which requires my calculator to do it for me. 225. 225. Here I have to divide 196 by 14. And, okay. And I get 14. So F is equal to 14 here. Okay. Make sure you have these rules in the back of your spiral so you can use them on tests and homework, etc. Number 26, A says the rule of the following sequence is this. So this is the rule. Whatever I plug in for N, I'm going to get something different for K. What is the 10th term? So that means N equals 10 of this sequence. Okay, so I'm going to plug 10 right into N. So I have K is equal to 3, and since they're close together with no operation, that's going to be times minus 1. And I have to do multiplication first, so I have 30 minus 1, and that equals 29. What pattern do you recognize in this sequence? Okay, let's see. 2 plus 3, it's plus 3. Plus 3, plus 3. Is that right? It sure looks like plus 3. Okay. Next. All right, refer to the figure to the right to answer the problems 28 and 29. It says, name the acute. So this is less than 90. Obtuse, greater than 90. And right is 90 degrees. So the way we know we have a right angle is normally they're indicated by these little squares. Okay? So I know that my right angles here are angle D, and this is the angle designation here, and angle C. Okay? So this angle, this is going to be greater than 90. So angle A is what we call obtuse. This angle is going to be less than 90. So angle B is what we call acute. Okay? Let me change my colors here so we can go on. Name a segment. So remember, a segment is just part of a line parallel to DA. So if this is DA, we need a segment that does not run into it. So DC runs into it, AB runs into it, but BC does not. BC is parallel. So the way that we write a segment is we write the letters, and it could be CB as well. It doesn't matter. It could be either way. But we put that little line above it. And then I'm going to change colors again because we're still talking about this figure. Name a segment, part of a line, perpendicular. That means it makes a 90-degree angle to DA. So let's see. This is DA again. Okay, this makes a 90-degree angle, but it doesn't touch DA. So it's going to have to be DC. And you can write it like this or like this, either way. I think that might be our last one, unless we have... Oh, that is our last one. Okay. Well, if you have any questions, please let me know. Thank you so much for your attention, and have a great day.